In this video, I am going to show you how to find deflection at the point of a beam using moment area method. And this is the example 4 problem. You can see the problem here. It says determine the deflection at C of the beam shown in figure, and E and I values are given. And you can see the beam here ACB, and A is a pin support while B is a rocker support. At A, there is a moment of 5k feet, and they are asking deflection at point C at the middle of the beam. So all the lengths are given here. Overall beam length is 24 feet. As you know, in moment area method there are two theorems. So if we have to find slope of a beam, we have to use theorem 1. But here they ask deflection. So therefore we have to use moment area method theorem 2. So we will see how we find deflection using moment area method theorem 2. Our first task is to find in support reactions. So at A there is a pin support, therefore we have to mark two force components, one horizontal force component and one vertical force component. At B there is a rocker support, therefore we have to mark one vertical force component. So next I will consider sum of all the horizontal forces. So if I consider horizontal forces, I will have Ax equals 0 because there are no other horizontal forces. Next I am going to take moment about point A. So if I take moments about point A to the counterclockwise direction, I will have By equals 5k over 24. Next I am going to take moment about point B to the clockwise direction. So then I will have Ay equals minus 5k over 24. This is the free body diagram, and you can see support reactions are marked in this diagram. So next I am going to draw bending moment diagram. So as you can see, there are no point loads or distributed loads on this beam. Therefore we can easily draw bending moment diagram for this AB beam. For that I will cut this beam through a random point like this, and I will mark this distance as x. Then I will redraw it. So this is the part of the beam. This is point A and this is the moment at point A. This is the support reaction at point A. And this is the distance, I marked it as x. This is the shear force, I marked it as V. This capital M is the bending moment. So next I am going to find capital M, which is bending moment. Let's say this point I marked as P. So next I am going to take moment about point P. If I take moments about point P, I will have M equals minus 5k over 24 times x plus 5k. This is the equation of bending moment diagram. Here I am going to draw bending moment diagram. So this is the equation we got. M equals minus 5k over 24 times x plus 5k. So as you can see, this is y equals minus mx plus c type. So I can easily draw this bending moment diagram. Its shape is like this. And value of maximum bending moment is 5 and beam length is 24. So we have to find the deflection of point C. So point C is at the middle of the beam. So therefore we have to find the moment value of middle of the beam. For that I have to substitute x equals 12 into this equation. When x equals 12, m equals 2.5. So I can mark it right here. When x equals 12, m equals 2.5. So this is the bending moment diagram. But in moment area method, we have to find m over EI diagram. So it's simple. We already have bending moment diagram. Then we just have to divide these values from EI. So next I will show you m over EI diagram. So this is the m over EI diagram. I just divided these moment values from E and I. Next I will explain you this diagram. So this is the deflected shape of the beam. So you can see there is a blue line, right? So it's a sagging shape. So this is the deflected shape of AB beam, and you can see this is the point A, it's pin support, and this is point B, it's a rocker support, and middle of the beam I marked it point C. So we have to find the deflection of point C, right? And dimensions are given. Overall beam length is 24 feet. Distance to point C is 12 feet because it's lay on middle of the beam. Next I am going to draw tangents, right? At B I will draw a tangent line. So you can see this is the tangent line at B, and I will mark it as tan B. Then at point C I will draw a tangent line. This is the tangent line of C, and I marked it as tan C. Please keep in mind this tangent C is not a horizontal line because this beam is not a symmetrical beam, right? Therefore we can't say this is a horizontal line. So please keep in mind. Right, next I am going to mark deflection at point C. So you can see I marked it as delta C. This is the deflection of point C. So actually this is the answer. We have to find this delta C. Then TAB. So you can see this is the tangent B, right? So I mark deflection of point A respect to tangent B. You can see this line I marked it from tan B to point A. So this is the TA respect to B, or we can say TAB. Then TCB. I marked deflection of point C respect to tan B. So you can see I measured it from tan B to point C. So this is the TC respect to B. So we can say TCB. So using moment area theorem, we can find these two values. Only we have left is delta dash. So it's simple, no, delta dash is equals to delta C plus TCB. So those are the notations. Next I will show you simple theory. So you can see there is a large triangle PQT and there is a small triangle SRT. So if we have these type of two triangles, we can say this PQ length over this PT length equals to SR length over ST length. So I can say PQ over 24, 24 is this overall PT length equals to SR length over 12. So this theory will be needed in future calculations. As I told you before, we can find TAB and TCB using moment area method. So next I am going to do that thing. So I am going to find TAB and TCB using moment area method. First I am going to find TAB. So you can see here M over EI diagram. So using M over EI diagram I can find TAB. So there are two letters, right? A and B. First we have to find the area between A and B in M over EI diagram. So you can see here ACB I marked here, and area between A and B is this overall triangle. So we have to find area of this triangle. So it's simple, no? Area of a triangle equals to half times this AB length. AB length is 24. 12 plus 12, 24 times this side. This side is 5 over EI. This is the area of this triangle. Next, I have to take moments. So in this moment area method theorem 2, we have to take moments. So here, as I told you, there are two letters, left side letter and right side letter. So left side letter is capital A, right side letter is capital B. So in this moment area method theorem 2, always we have to take moment about this left side letter, so which is capital A. Therefore we have to take moment about this capital A point. For that you have to know the centroid of a triangle. Here I will explain you centroid of a triangle. So look at this triangle, its height is h. Let's say its centroid is lay on this point. So top to centroid height is 2h over 3 and centroid to bottom height is h over 3. So if you have this type of triangle, so if this is the centroid, overall length is h, this length is 2h over 3 and this length is h over 3. Now we know how to find centroid of a triangle. So let's say here the centroid of this triangle, I marked it as C dash. So distance to centroid, I mark it like this, and this length is equals to h. H is the overall length, it's 24 over 3. This is the distance to centroid from point A. So now we can easily find TAB using moment area method. So you can see equation of TAB here. TAB equals 1/3 24 times 102 25 times 5. So here this is the distance to centroid from A. This is the area of the triangle. So when you simplify it, you will have, this is the TAB. Next I am going to find TCB. Here also two letters, C and B. First we have to mark the area between C and B. So this is C, this is B. Area between C and B is this area. So we have to find this area. This area is equals to half times length of CB, it's 12, times this side. This side is 2.5 over EI. This is the area of this triangle. Here also two letters, left side letter and right side letter. So we have to take moment about left side letter, which is capital C. So we have to take moment about this capital C point. Then we have to know distance to centroid from C. So let's say this is centroid. So this length is equals to, overall length is 12 over 3. This is the distance to centroid from point C. So you can see the equation here, TCB equals 1/3 12 feet times 102 times 12 to 2.5 over EI. This is the distance to centroid from A. This is the area of the triangle. So once you simplify it, you will have 60K over EI. So now we know value of TAB, value of TCB. Next, I will use this relationship. Here you can find two triangles. So this red triangle and this green triangle. Right, there are two triangles. So I can say TAB over this length is 24. TAB over 24 is equals to delta dash over 12 feet. So I will write it here. TAB over 24, TAB is this length, 24 is this overall length of AB, 12 plus 12, equals delta dash is this length over 12, 12 is this length, right? Here I can simplify it, 12 times 1 and 12 times 2. So I can write TAB over 2 times delta dash. So here I can write equation for delta dash. Delta dash is equals to delta C plus TCB. Right? So next I am going to substitute this relationship to this delta dash. So then I will have TAB over 2 equals delta C plus TCB. Here this is the answer. We have to find this delta C. This is the deflection of point C. So I can solve this for delta C. Delta C is equals to TAB over 2 minus TCB. Now we already know the value of TAB and TCB. So that means we already have the answer. We just have to substitute those values to this equation. So this is the final step. Delta C is equals to TAB over 2 minus TCB. Earlier we found the value of TAB and TCB. We can substitute those values into this equation. Then I can simplify it and finally get the answer as delta C equals 0.511 inch. Unit conversions are there, so I'm not going to explain this. I just mainly focus on the theory of moment area method. Like that, you can find deflection of point C using moment area method theorem 2. Please like, comment and share this video. To watch future educational videos, please subscribe Educate Today YouTube channel. Thank you.